Guys, welcome to the assembly language tutorial. In this tutorial we will be learning some assembly language and we will be discussing registers and their usages. If you have a knowledge of languages like C, Pascal, Java, then it is good. If you don't, then it does not have that much impact. If you are learning some other language, then architecture is not so important, but in assembly language the architecture is very important. So we will be discussing the architecture of the 8086 microprocessor first. Well, if you are looking for assembly language tutorial, then you must have some knowledge about the number system, and I think you have it. For those who don't know, assembly is a low level language, means it does not have that English syntax that a C++, Java have. Well, a computer system is made of three main blocks: a memory system, a microprocessor, and I/O system. These are interconnected with the buses. And what does a memory system? A memory system is a RAM, ROM, cache, and all kind of the RAMs, such as DDR RAM, EEPROM, etc. Microprocessor is the heart of the system. Without it, computer system is nothing. Example of the microprocessor: 8086, 8088, 80186, Pentium, Pentium 3, Core 2, etc. etc. And the I/O system are the printer, floppy, mouse, serial communication, tape backup, etc. Buses. Let's talk about buses a little bit more. There are three types of buses: data bus, address bus, and control bus. Data bus can be bidirectional, mean it can be used to send or receive the data. Address bus is a unidirectional, that a microprocessor will generate the address and it will send it to the memory system. And a control bus can be unidirectional or the bidirectional, means a microprocessor will issue a control signal that a some device is read only or write only, and the device can also issue some signals to the microprocessor. So it can be unidirectional or the bidirectional, depends upon its usages. Now we will look inside the CPU. We will be discussing 8086. So here are its registers. It has some general purpose registers which are AX, BX, CX, DX, and all other. Now let's talk about the AX. AX is the accumulator register, mean it is used to store the result of addition or subtraction, but it is a general purpose register. It depends upon the programmer to save what it wants in it. Well, it is a 16-bit register and its lower byte is called AL, its upper byte is called AH. Mean if you want to address its lower byte, you can just put AL and the data will be stored or retrieved from the AL. And similar is the case with the AH. Similarly, the BX is also a general purpose register and it holds the base addresses and all that stuff. And the important one is CX. It holds the count for various instructions. Means if you are generating a loop, it will hold the current loop status, or like C, if I is equal to I plus plus, and I is the variable which counts how many times the loop will be executed in assembly. The CX can do the same stuff. And the DX is a data register and it's also a multi-purpose register. It depends on the programmer to do whatever you want with it. Source index register, destination index, base pointer, and stack pointer. Some people call the stack pointer as also as a base general purpose register, and some call it a special purpose register, and we will talk about the stack pointer later. And there are some special purpose registers too. Before that, let's have a look at the segment register. Well, CS is called the code segment. It's point at the segment containing the current program, means the code segment is a section of memory that holds the code. By code we mean programs and procedures that are used by the microprocessor. We will not go into the further detail of the CS, that how it operates in the real mode, protected mode. It's basically idea to give an overview about that. The DS, the data segment, it usually points at the segment where the variables are defined. You will know it in more detail when you will be doing some assembly language or you're making some program. You will be doing the exact how these registers operate and their usages. And the next are special purpose registers, and one of them is the IP, and it is an important one. It's called the instruction pointer. It means that it's point to the next instruction that the CPU is going to execute. IP register work together with the CS, that the CS defined that in which segment of the memory the code is placed, and the IP is then appended with the CX, and it tells the microprocessor which instruction should be executed next. And the next one is the flag register. Flag register is a 16-bit register, and it's modified automatically by CPU after mathematical computation like addition, subtraction, comparison of two numbers. And it has 16 bits like parity bits, carry bit which shows that the carry is generated or not, overflow bit that shows that the overflow is occurred, a sign bit that shows the number is signed or unsigned, and like 0 bit which shows that the result of some operation is 0 or not, and all that stuff we will be discussing it later. For now I think it is enough for you, and you have gained enough knowledge about the register of the 8086. Thank you for listening.